Alright, welcome to this video. Is focused on the concept of convolution. In the previous video, we said that the Laplace transform is linear and the inverse of the Laplace transform is also linear. So linear here means that the Laplace transform of the sum of these two functions f and g is equal to the Laplace transform of each of these functions, right? And it's also it's the same for the Laplace inverse. So Laplace inverse of these two functions, the sum is the Laplace transform of inverse of each of these functions. All right, the question is the following. Can we also say that the Laplace transform of the product of these two functions is equal to the product of the Laplace inverse of each of them? So this is my question. Is the Laplace inverse of f of s times the Laplace inverse of g of s. Can we say this? No, unfortunately we can't do that. That's why we have to introduce this concept of convolution. We will say that this is different, okay? But the good news is that there is a concept called convolutions that deal with this type of with the product of two functions. Then by definition, the convolutions of two functions f and g is denoted by f times g, or convolution g of t. This is the notation, and it is defined as the integral from 0 to t f of omega times g of t minus omega times d omega. Okay, so the convolutions of the function f and g is the integral from 0 to t of the function f of omega times g of t minus omega d omega. Now let's introduce these two this theorem. It's called the convolution theorem. If the functions f and g are the Laplace inverse f and g respectively, then we have the following. The Laplace transform of f times g of t is equal f of s times g of s. So this is equivalent to f convolution g of t is equal to Laplace inverse of f of s times g of s. Alright, take note of this. The convolution of these two functions, f convolution g of t is equal g convolution f of t. Can we prove this? Yes, we can prove this. By definition, we know that the convolution f with g of t is the integral from 0 to t f of omega times g of t minus omega d omega. Alright, if we let v be t minus omega, then d omega is equal minus dv, and the convolution f times g of t is the integral. So in this case, of course, I want to write this negative sign here. So when omega is equal 0, then this become t, v become t, and when omega become t, then v become 0 of f of omega. Omega here is t minus v, and the function g of v dv. Alright, here with the negative sign, we can change the limit in the following way. The negative sign and the limit will just change, and this become the integral from 0 to t of the function f of t minus v times g of v dv. Alright, we can change the position of these two functions. It doesn't matter. So this is the integral from 0 to t of g of v f of t minus v dv. All right, at this stage, by definition of the convolution, this is exactly the convolution of the function g times f of t. We have shown that the convolution of the function f with the function g is equal to the convolution of the function g with the function f. In the next video, I'll give you some example where you apply the convolution. Thank you.